Welcome to AP Calculus Definite Integrals Part 3, Growth and Decay. This concept is as much an Algebra 2 concept as it is in AP Calculus. In fact, what we start off here will be mostly just the AP Calculus part of it, and then we'll go from there to show how that is related to Honors Algebra 2. In many applications, the rate of change of a variable y is proportional to the value of y. If y is a function of time, then that proportion can be written as this. Dy dt equals ky. Remember, if something varied directly, it was always that constant of proportionality. Okay, so a lot of times you're going to have this. The rate of change of a variable is going to be proportional to the value of y. And here is where all the calculus comes in. Okay, so that certainly looks like a separable differential equation, doesn't it? Sure it does. So let's go ahead and solve this differential equation. Okay, divide both sides by y. So you've got 1 over y dy dt equals k. Multiply both sides by the differential dt. 1 over y dy equals k dt. Integrate both sides. Sounds familiar, doesn't it? 1 over y. Whoa, 1 over y? I don't think that's 1 over y. Do you? Okay, that would be the ln of y plus c equals kt plus c. Correct? Yes. Okay, subtract c from both sides. The ln of y equals kt plus c. Exponentiate both sides. Y equals e to the kt times e to the c. And remember, that's just going to be a constant. So y equals c e to the kt. And that ends the calculus portion of growth and decay. The whole calculus portion of growth and decay is to come up with this equation here, and then the rest is Algebra 2. Alright, something I forgot to just add on. I'm going to do that right now. Okay, this c right here, that will stand in the equation y equals c e to the kt. C will be the original amount. Whoops. K will be the proportionality constant. Oh, good writing, Manning. If k is greater than 0, it is exponential growth. And if k is less than 0, it will be exponential. Wow, I can't even write. Exponential decay. Alright, just to let you know what all those numbers mean. Now let's go on to our first example. Go ahead and read that, and then we'll attack it. Now that you're done reading it, here we go. Alright, we'll start out with y equals Okay, the original value 55 e to the, well, proportionality constant is 0.2 t. Find the value of q when t equals 8. Y equals 55 e to the 1.6, because 0.2 times 8, 1.6. So the value of that quantity q, in this case, 272.41678. Yes, growth decay seems pretty easy. Yes, you're right, it does. Alright, go ahead and read that. Pause while you're reading, and you'll notice that I have not given you a proportionality constant. Just giving you time to pause. No, really, just giving you time to pause. Alright, so we don't have a proportionality constant, so we're going to have to use what's given up there to find a proportionality constant. Alright, y of 1 equals 1200 e to the k. Okay, the t is gone. So 1170 equals 1200 e to the k. Alright, now we can solve that equation to find out what our proportionality constant is. Of course, it's going to be decay, so it better be negative. 1170 divided by 1200 equals e. Wow, nice e. Guess what I was thinking? E to the k. Take the natural logarithm of both sides, and k is going to be, what do we got here? Negative 0.02532. Okay. Now, the question asks us to find it at what time will the concentration be 80 parts per million. So 80 equals 1200 e to the negative 0.02532 t. Okay, divide both sides by 80. So 80 over 1200 equals e to the negative 0.02532 t. Take the natural logarithm of both sides. So the ln of both sides, and we will end up with t being approximately 107 days for that oil spill to get down to something that we like. Alright, let's go ahead and move on. Half-life. It refers to t, a length of time. It's the amount of time it takes for a quantity of material to decay down to half of its original size. Alright, using the y equals ce to the kt, y of 0 is going to equal c. And y of h, its half-life, will yield us half of c. Right? Because the half-life will reduce it down to half of what it was. So we have two things that are both equal to y of h. So 1/2 c equals c e to the hk. Divide both sides by c, 1/2 equals e to the hk. Take the natural logarithm of both sides. So the ln of 1/2 equals hk. So the proportionality constant is always going to be the ln of 1/2 over the half-life of any substance. So the proportionality constant will always be ln of 1/2 over h. And that will help us when we need to do problems that have half-lives in them. And this will lead us to example number 3. A radioactive substance has a half-life of 481 years. Find the decay constant. Wow, here, let me fix that quick. Sorry about that spelling problem. Alright, here we go. The ln of 1/2 all over 481 will be our proportionality constant. So our proportionality constant with a substance that has a 481 year half-life is going to be negative 0.00144. Okay, then we can use that to find out how many days it will take for a substance to get down to a certain value. Alright, this concludes AP Calculus Definite Integrals Part 3, Growth and Decay.